Personal loans, such as student loans, credit cards, and mortgages, all operate based on the principle of compound interest. There's a formula that we can use to determine regular monthly payments for this type of loan. And this would be for the case where you would want to make a regular payment each month. So you would want to find out in total what is the amount of the compound interest that accrues over time, and then how do we divvy that up evenly so that you're paying the same amount each month or each year or whatever payment period you choose. One thing that I'm often asked is why do we need this formula? I've seen students that will use the compound interest formula, okay, which you may remember is this, and they'll take that compound interest formula, which calculates the total accumulated balance, and then they'll just divide that by however many payments they would like to make. So there's an easy explanation for why this doesn't work, and that's the fact that you are making regular payments. So the amount of interest depends on the principal balance, right? So in this formula, this is assuming that the principal balance stays the same over the entire period of time for that interest calculation. However, any sort of these situations, like a student loan, you would be reducing the principal balance each month, and so there would be less interest over time. Same thing with mortgages. You're paying that mortgage off, so each month there's less and less principal balance, which means that less interest accumulates over time. All right, so we can look at this method at the end and kind of make a comparison, and I think you'll see based on specific examples that that does work out to be a different number, and that would actually charge you more interest if you do it that way. Another note of caution for using this loan payment formula, right? N is the number of payment periods per year, and we're also assuming with this formula that the number of times per year that interest compounds is the same as the number of payment periods. If that's not the case, then you would need to modify this formula a little bit. All right, so in other words, if this is going to be used to calculate the number of monthly payments, then you would need to assume that interest also compounds monthly. So let's look at an example of a student loan, and we'll use that monthly payment formula to calculate the monthly payment as well as the total amount that will be paid for this loan, and then how much of that is interest. All right, so we want the principal balance, which is $7,500. Right. Now, I'd like to make a separate video to go into more detail about student loans, but for now, I just want to clarify that this is the student loan amount after graduating from college, which means that there's some interest wrapped into this, okay? Because in reality, for at least for the federal unsubsidized student loans, whatever you borrow when you begin college does accrue interest even while you're in school, right? So this student would have borrowed something less than $7,500, and then this would include all of the interest. Unless there is another situation, if the student paid off all of that interest during school, then by the time they graduate, perhaps they would just be left with whatever the amount is that they borrowed. Okay, so with that being said, we can use this formula, fill in all of the rest of the relevant information. And you'll notice here that N is the number of payments per year, and we're asked to find monthly payments. So that's why N is 12. And then the time, the loan term is 10 years. All right, so that's fairly standard for student loans to have a repayment term of 10 years. Okay, so if you go ahead and make that calculation, you'll end up with about $95.01. All right, so that's the monthly payment amount after college that this person would pay for the next 10 years. Typically, there's also a 6-month grace period after graduation, and then payments would start after those 6 months. Okay, how much does the student pay altogether? So we want to take into account the principal balance as well as the interest. Right, so this monthly payment is paying off both the principal and the interest. So what we need to do is just find the total number of payments and then multiply by the monthly payment amount. Right, so they're making 12 payments per year times 10 for 10 years times $95.01 for the amount that they're paying each month. and then that's a total of $11,401.20. Okay, so you can see that that's more than the principal. So if we just take that number and subtract the principal, then that would tell us how much of that is interest. And that turns out to be $3,901.20. All right, so that's all in interest. So you could actually say that the true cost here is not really $7,500. The true cost is closer to $11,500. So because of the nature of these types of loans, the ones where we make fixed payments, more of the monthly payment amount goes to interest at the beginning of the loan than it does towards the end of repaying that loan. All right, and that's because of the fixed payment. So, when your principal balance is very high, like in the example of the student loan, right? If the principal at the beginning is $7,500, well, then the interest on that amount is going to be higher, of course, than at the end of the loan when we only owe like $10 or something like that. So in order to keep the payments fixed so that you don't start out with a larger payment and then work your way down to a smaller one, then we need to distribute the interest so that more of it is paid off at the beginning. Now there are a few ways to be able to see what portion of the payment is going towards interest and what portion is going towards the principal. One option is an amortization table. And this is literally just a table that shows you the portion that goes toward interest and the portion that goes toward principal. So typically they would be a lot longer than this. This is just the first 3 months of one of these. But if you had, like a 10-year student loan, you'd have 120 different rows here showing these amounts. All right, and then the first column shows the amount that's going toward interest, right? And then if we have a fixed payment of, for example, $95.01 on the student loan, then whatever's not going towards interest goes towards principal. So you can just subtract away the interest and see what's left. Okay, and then the new principal of the loan, your loan's not decreasing by your payment amount, not by $95. The principal balance is just decreasing by that smaller amount that goes towards principal. Okay, and then on the right, you can slowly see that balance shrink from the original principal of $7,500 all the way down to the end of the table where it will be $0 once it's paid off. Another option for seeing what portion goes towards interest and towards principal is to just look at a visual picture of that. So here's an example of a graph that shows some blue interest amount and some pink principal. And as you can see, the areas here are just about equal. So that the interest amount is fairly significant. It's not a small amount compared to the principal. Sometimes the interest can even be more than the principal on the loan. To see another example of the total interest amount that accumulates, let's look at an example that deals with a mortgage. Right, so let's consider a home that costs $100,000, or that's the amount of the mortgage that needs to be borrowed. And let's say you have two choices, either a 30-year loan with an APR of 5% or a 15-year loan with an APR of 4.5%. So because the term of the loan is shorter, the bank's offering a better deal with the interest rate. And that's really the only difference between these two choices. We're assuming that the closing costs are the same in both cases. All right, so using that information, we can calculate the monthly payment in each case. Right, so for example, for the 30-year 5% mortgage, principal is $100,000. APR, we would use 0.05. And then again, we aren't told specifically N equals this number, but we're calculating monthly payments, so that means N is 12. And then we have negative 12 times, in this case, 30 for the number of years. Okay, and then the only difference with a 15-year mortgage will just be the interest rate and the term in years. Okay, so calculating out those two amounts, on the one hand, we have a payment of $536.82. And for the shorter term, a monthly payment of $764.99. So even though the interest rate is a bit lower for that loan, we're paying it off twice as fast, so it does make sense that the monthly payment amount should be greater. But notice it's not exactly twice as much, and that's because you are saving some money in interest. You're not accumulating as much interest to pay off, so you don't need to pay twice as much in order to pay that off. Now let's look at the total amount that accumulates for the loan. So on the one hand, we're paying 12 payments per year for 30 years in this amount, $536.82, and that turns out to be $193,255. And then on the other hand, 12 payments per year for 15 years with that slightly higher amount, and that works out to be $137,698. Okay, so those are the total amounts. The principal was $100,000, so if you subtract that away, you can see that you're paying about $93,000 versus about $38,000. So that's a significant savings in the amount of interest. On the one hand, the interest almost equals the principal of the loan, and on the other hand, it's quite a bit lower. If you were in this situation with buying a home and you wanted to try to save some money in interest, there are a few options for doing so. They do involve prepaying. So one option would be to stick with the longer loan and then just make extra payments to principal each month. Right? So looking at this chart of interest versus principal, right? In that first case with the $537 payment, right? Only about $153 goes towards the loan principal, right, versus $384 going towards interest, and that's about 5 years into the loan, right? So let's say you make that payment, and then you decide to make an extra payment of another $100 specifically towards the principal, right? Well, what effect will that have over time, right? So what we're saying is that you're initially reducing your principal by $100, and let's say you do this during the first month of the mortgage, not 5 months in, right? So the amount you're actually saving here is not just $100, but it's the $100 plus however much interest would accrue over the next 30 years, right? So if you use the compound interest formula to see what that $100 is worth at the end of 30 years, okay, you would do the principal times 1 plus APR, which was 5%, okay, over 12, and then times the exponent of 12 times 30, right? So after 30 years, the $100 would grow to be about $450. All right, so by just making one extra payment of $100 during that first month, it saves you $450 over time, and then that would just double. So if you paid an extra $200, you'd save $900 over time, and so forth. A second option is to just choose the shorter term mortgage, right, versus making those extra payments. Right, so we saw if that's the case, if you choose this 15-year mortgage, then you're still saving quite a bit, more so than if you did the 30-year mortgage. However, the disadvantage of this is that you are locked into this higher monthly amount. Right, so if you kind of want the best of both worlds, then an option would be to go for the 30-year mortgage and then just make extra payments to principal as much as you can. But if you're not able to make that higher payment 1 month, you could always default back to the minimum that's required. So let's compare those two options, namely taking the 30-year mortgage and making extra payments as much as possible versus taking the shorter mortgage and being locked into that higher monthly rate. All right, so let's say you take the 30-year loan, but you do try to pay it off in 15 years by making extra payments. All right, so you might want to know how much would you need to pay each month in order to do that. All right, so we use that monthly payment formula, and we go with the $100,000 principal But this time we'll go with the higher rate. So we're assuming somebody took the 30-year mortgage with the rate of 5%, but then we're going to adjust the term to be 15 years and see what happens then. Okay, so we've got negative 12 times 15 as the exponent, right? And this would give us the payment if we're trying to pay off $100,000 in 15 years. So that's going to work out to be $790.79. So you can compare that amount to the 15-year mortgage at 4.5%, and that one required monthly payments of about $765. All right, so the difference here is the higher interest rate. If you're taking the 30-year loan and just trying to pay extra, you're still paying 5% interest per year versus 4.5%. So you're going to need to pay a little bit more each month in order to be able to pay off the loan in the same amount of time. But again, you've got more flexibility because if you ever can't pay $790, you can default to the lower $537 payment per month. Okay, so that's an overview with a few examples of how this loan payment formula works. We looked at student loans and mortgages, but again, this payment formula would also work for credit cards. The interest compounds in the same way, and typically people make regular credit card payments to try to pay that off. Really, the only difference with that is that credit cards don't usually have a fixed payoff amount. The minimum payment might vary month to month, whereas the student loans and mortgages, you're usually locked into a fixed monthly payment. Okay, in the next video, we will take a look at student loans in a little bit more detail, but that's it for now.